Welcome to the DIY Honda Garage channel. DTC B1230 indicates an issue with the sunlight sensor circuit, specifically designed to control functions associated with the vehicle's climate control system. The sunlight sensor itself plays a crucial role in monitoring ambient light conditions to effectively regulate temperature and airflow within the vehicle. This component is typically located near the windshield on the dashboard, where it has direct exposure to sunlight. When the system detects a short circuit in this sensor circuit, it triggers the DTC, warning the driver of a malfunction. As a result, the climate control's efficiency may be impaired, leading to discomfort within the cabin. Therefore, proper diagnosis and resolution of this error code are essential for optimal vehicle performance and passenger comfort. DTC B1230 is triggered by a short circuit in the sunlight sensor circuit. The sunlight sensor monitors external light and provides data to the climate control unit, which is responsible for adjusting cabin conditions. This sensor is typically positioned on the dashboard near the windshield to ensure it accurately assesses sunlight exposure. When a short circuit occurs, it causes the sensor to malfunction, leading to potential disturbances in climate functionalities. Consequently, the vehicle may not optimize its air conditioning or heating based on the sunlight detected, affecting passenger comfort and overall system efficiency. Identifying and addressing this DTC ensures that the climate control system operates as intended. Several potential causes can lead to triggering DTC B1230. First, wiring issues, such as fraying or damage, might create a short circuit, disrupting communication between the sunlight sensor and the climate control unit. Secondly, the sensor itself may have failed due to environmental factors or wear over time, resulting in incorrect readings. Lastly, problems with the connectors, such as corrosion or poor connections, can impede the flow of signals to and from the sensor. Each of these factors must be investigated thoroughly to pinpoint the exact reason for the DTC activation. Understanding these possible causes helps technicians take the right steps in the troubleshooting process to ensure accurate diagnostics. When DTC B1230 is present, several symptoms may arise, indicating a malfunction in the sunlight sensor circuit. Drivers may experience irregularities with the climate control system, where the air conditioning or heating may not respond effectively to changes in sunlight. This can lead to discomfort, especially during extreme weather conditions. Another symptom could be an erratic operation of temperature regulation, as the system fails to adjust appropriately based on sunlight exposure. Additionally, the dashboard warning light may illuminate, alerting the driver to the issue. Recognizing these symptoms early could assist in taking timely action to troubleshoot and remedy the problem, enhancing vehicle comfort and reliability. The first step in troubleshooting DTC B1230 involves using the Honda Diagnostic System (HDS) to clear any existing diagnostic trouble codes, DTCs. Clearing the DTCs helps reset the vehicle's computer system and allows technicians to determine if the issue is ongoing or intermittent. After clearing, it's important to switch the ignition to the lock 0 position and then back to on second. This action prepares the vehicle systems for the next part of the self-diagnostic procedure. It sets up the climate control unit for a fresh diagnostic check, ensuring accurate results for subsequent tests. Clear communication with the diagnostic tool is essential to move through the troubleshooting steps effectively. Following the initial step, the next action is turning the ignition switch to the lock 0 position and then back to on. This step is crucial for properly initializing the vehicle systems after clearing DTCs. By moving the ignition switch through these positions, the vehicle's computer registers this change, essentially rebooting the system. This process can resolve minor glitches in the electronics while allowing the climate control unit and sunlight sensor to reset. It also prepares the system for the next part of the diagnostics, making certain all operations are reset and ready for further checks. This step is critical in ensuring that all components are functioning during the diagnostic self-test. The third troubleshooting step involves conducting a self-diagnostic function using the HDS or directly through the climate control unit. This diagnostic test comprehensively assesses all related systems, checking for errors and ensuring that all wiring and connections are functioning as expected. The HDS provides precise data about any existing issues, including potential shorts or failures in the sunlight sensor circuit. If using the climate control unit directly, the technician should follow the incorporated procedures to initiate the diagnostics. This step is imperative for collecting diagnostic data and understanding what other issues may accompany DTC B1230. A thorough self-diagnostic function enables accurate follow-up steps for further troubleshooting. After completing the self-diagnostic function, the next step is to check for any new or existing DTCs. This verification step is crucial to determine if DTC B1230 still persists, or if the system has cleared itself of errors. If the code is indicated again, this suggests that the issue remains unresolved and further investigation is necessary. Conversely, if DTC B1230 does not appear, it may signify an intermittent failure, likely caused by a loose connection or a temporary fault. Regardless of the outcome, this step is critical in guiding the next actions. Proceeding with further diagnostics is important if the DTC reappears, as it hints at a deeper issue with the sunlight sensor circuit or its connections. The fifth troubleshooting step entails turning the ignition switch to the lock 0 position once again. This important action is necessary before disconnecting electrical connectors for safety reasons, ensuring that no power is running through the system while performing these checks. Disconnecting components while the ignition is on can lead to further complications, including potential damage to electrical systems. Once the ignition has been switched off, technicians can safely proceed to disconnect the sunlight sensor and climate control unit connectors for further diagnosis. Ensuring the ignition is in the off position forms part of standard safety protocols during vehicle diagnostics and repair. In this step, the technician must disconnect the 5P connector from the sunlight sensor. This action allows direct access to the sensor's wiring, which is crucial for further testing. With the connector removed, safety is assured, and continuity tests can be conducted without interference. The sunlight sensor wiring must be checked to ensure it is not compromised or experiencing a short circuit. Proper disconnection of this component helps prevent accidental damage during the diagnostics. Completing this step accurately prepares the system for more in-depth electrical checks, ensuring a systematic approach to diagnosing and troubleshooting the underlying issues related to DTC B1230. Following the disconnection of the sunlight sensor, the next step involves disconnecting the climate control unit's B connector, labeled 16P. This specific connector contains terminals crucial for the operation of the sunlight sensor circuit and its communication with the climate control system. Disconnecting this connector allows for individual testing of the connection against the vehicle's grounding. It is important to ensure this is done methodically to avoid connection issues later on. Once the B connector is removed, the technician can then conduct a continuity test between terminal number 3 and body ground. Completing this step efficiently ensures the integrity of wiring and helps identify if the sensor is functioning correctly. In this critical step, technicians will check for continuity between climate control unit connector B, terminal number 3, and the body ground. This test is paramount in determining whether there is an intact electrical path between these points. A successful continuity check signifies that there is a proper ground connection, which is essential for the proper functioning of the sunlight sensor. If continuity is established, this confirms that there is a signal flow, thus indicating the problem lies elsewhere, likely a short circuit affecting the wiring between the climate control unit and the sunlight sensor. If continuity does not exist, this suggests a disconnection or break in the wire, prompting further investigation into the wiring harness for potential shorts or damage. Every part of this step is crucial for ensuring that the climate control functions optimally. The 9th troubleshooting step requires disconnecting the climate control unit's A connector, identified as 28P. This connector serves as one of the key communication links within the climate control system, and disconnecting it allows for isolated testing of the connections related to the sunlight sensor. By performing this action, technicians can effectively narrow down potential issues in the circuit without interference from the rest of the system. Ensuring that this connector is properly disconnected paves the way for the next set of continuity checks, which are necessary for confirming the integrity of the wiring between the connectors. Properly addressing this stage sets the groundwork for a thorough investigation into the climate control circuitry and its components. In this final troubleshooting step, technicians will check for continuity between climate control unit connector A, terminal number 13, and connector B, terminal number 3. This continuity test assesses whether there is an unbroken electrical path between these two terminals, essential for the signal transfer necessary to operate the sunlight sensor effectively. Establishing continuity is crucial as it indicates that the wiring between the climate control unit and the sensor is intact. If continuity is confirmed, it suggests that the issue lies elsewhere, possibly within the sunlight sensor itself or the connectors. Conversely, if no continuity exists, it points towards a wiring fault that could lead to the activation of DTC B1230. This thorough checking of connections ensures the reliability of the repair process. After completing the troubleshooting steps and making any necessary repairs, it is pivotal to conduct a final verification test to ensure proper operation of the climate control system. This involves turning on the vehicle and verifying that the sunlight sensor and other related systems are functioning as intended. Technicians should utilize the HDS to check if any DTCs persist. If DTC B1230 no longer appears, it indicates that the issue has been resolved appropriately. However, if it returns, this indicates that further investigation is needed to identify unresolved faults. This verification process confirms the effectiveness of the repairs and the overall health of the vehicle's climate control system. To prevent future occurrences of DTC B1230 and ensure optimal functionality of the sunlight sensor circuit, regular inspections of the vehicle's wiring and connectors are recommended. Technicians should routinely check for signs of wear, frays, or corrosion that could lead to faults, as these issues can often go unnoticed until a DTC is triggered. Keeping connectors clean and free from debris helps maintain robust electrical connections. Additionally, adhering to maintenance schedules provided in the vehicle's owner manual can substantially mitigate risks of electrical faults. Proactive care not only enhances the durability of the climate control system, but also contributes to overall vehicle performance and reliability. In conclusion, DTC B1230 reflects a significant issue within the sunlight sensor circuit and can adversely affect the climate control system of the Honda Odyssey from 2011 to 2017. Understanding the role of the sunlight sensor and effectively executing troubleshooting steps is vital for resolving this issue. Through detailed diagnosis, technicians can identify potential wiring issues, connector faults, or sensor malfunctions. Properly implemented repairs ensure the efficient operation of the climate control system, enhancing passenger comfort and the overall driving experience. Regular maintenance and proactive inspections play crucial roles in preventing the recurrence of this DTC, ultimately leading to a reliable and comfortable vehicle for all occupants. Please like and subscribe to the channel. See you next time.